So we're back to talk about even and odd functions. Now this is actually another case where this isn't new information. We actually have already talked about even and odd functions. We just didn't call them even and odd functions. So a function is an even function if the function is symmetric with respect to the y-axis. So remember in the first lecture we talked about symmetry, and we talked about it with respect to the y-axis, and we talked about it with respect to the origin. So that's what even and odd is. Now you might be wondering, there was a third one though. Wasn't there symmetry with respect to the x-axis? And absolutely there was. There was axis symmetry, x-axis symmetry. But if we think about graphically what that looks like, x-axis symmetry for any point xy, the point x negative y is also on that graph. This fails the vertical line test. And so any x-axis symmetry is not a function. And since we're just talking about functions here, there is no x-axis symmetry for functions. You have an even function, which has y-axis symmetry, and you have odd functions, which has origin symmetry. So if I wanted to figure out if something was even or odd, for even, I would replace all of my x's with negative x's. So replace x with negative x and try to get back the original function. If we're looking for odd, I would replace x with negative x, and I would also replace y with negative y and see if I can get back the original equation. All right, we're wrapping this up soon, I promise, okay? The graph of y equals x squared, okay? Now we graphed this in a previous lecture talking about how to plot ordered pairs just to get a function, or something similar to this. It was x squared minus 4, I think. But we plotted points to get to graph our function. I'm going to suggest now that we learn about the basic shapes of our functions, and we'll talk about that a little bit more in a few minutes. But for a quadratic, the vertex, this is the most basic quadratic function you can have, y equals x squared. The vertex of this function is at the origin, 0, and this is where I start to build my shape. From there, if you think about it, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So let's look at this pattern for right now. Since this is telling me to square something, going from x values that are 0, 1, 4, 9, or 0, going from x values, I should have written that up here, that are going from 0, 1, 2, 3, 4, 5, we get y values that range from 0, 1, 4, 9, 16, 25. And the distance between these are 1, 3, 5, 7, 9. And so this pattern continues forever. The next perfect square is 36, and that's 11 away. So this just keeps increasing by odd numbers. And so that's how I get my shape of my quadratic. I start here at 0, 0, and I go up 1, out 1. I go up 3, out 1. I go up 5, out 1. And then I would go up 7, out 1, up 9, out 1, up 11, out 1. And that gives me my quadratic shape, my parabolic shape. Now, next week, we're going to talk about transformations, graphing using transformations. And if you know this shape of this graph, then you can graph any quadratic that's in a specific form just by understanding how the different transformations affect the graph, and that's what we're going to talk about then. So knowing this basic shape is important, and actually knowing the basic shapes of several families of functions is going to be very helpful. So this is in page 70 and 71 in your book. There's a library of basic functions, and the book should have, your MyLab subscription should have come with the book. You should be able to look at that page. Okay, the ones that we're really concerned with are quadratics, absolute value, square root, and cube root. Okay, so those are the functions that we want to really understand the basic shapes of. So before I leave you today, we're going to graph a piecewise function. And I want you to really understand how a piecewise function works. Let me write this down. F of x equals x squared when x is less than 1, and 3x plus 1 when x is greater than or equal to 1. Okay, so this part in blue, this is the what. What is happening in the graph? What does the graph look like? Well, x squared, we just went over that. That's a quadratic. It looks like a quadratic. 3x plus 1, that's a line. We talked about that in the last lecture. 3x plus 1 is a line with a slope of 3 and a y-intercept of 1. What's in the green here is where it's happening, okay? So when I look at my graph, I should see a quadratic when my x values are less than 1. Did I write that down? Yeah. And I should see a line when my x values are greater than or equal to 1. So let's go ahead and I'm going to try to explain this in the best way that I can so that the most number of people understand it. Okay. So here's my coordinate plane. So my x-axis, y-axis, I'm going to be going up by 1s in both directions. All right, so I'm just going to start by graphing x squared. Okay, so if I graphed x squared, it would look like this. Up 3, out 1, up 5, 1, 2, 3, 4, 5, out 1, 1, 2, 3, 4, 5, 6, 7, out 1. 1, 2, 3, 1, 2, 3, 4, 5, and then 7 would be here. Okay, so this is my quadratic. It looks like this. And I should probably actually go through the points. All right. Here's what my quadratic looks like. Okay. I also have a line, 3x plus 1. 3x plus 1 starts at the y-intercept is 1. Let me do this in a different color. So that would be 1, go up 3 to the right 1, 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 down 3 to the left 1. This is how I would graph these individually. All right, and so I would just have this graph here, okay? Now, if I graph this, I'm almost there. However, looking at this graph does not pass the vertical line test, and this is supposed to be a function. So that's where the green part comes in, okay? This information over here. This says that I should have a quadratic when I'm less than 1, and I should have a line when I'm greater than or equal to 1. So 1, that's this vertical line right here. Okay? That's x equals 1. So that means on the left side of this green line that I just drew, it should just be a quadratic. So I'm going to follow the quadratic. And then on the right side of this, so I'm not including the quadratic on this line, to the right side of x equals 1, I should have a line. So that I'm including the line because it's equal to okay? Now, technically, every other part of this graph shouldn't be here, so this line that I drew just for reference is not actually part of the graph. The dotted quadratic that I had made before is not part of the graph. The line that's on this side is not part of the graph. So this is part of my graph right here. This is part of my graph right there. The axis is part of my graph. And the label of the scale. So this is actually what my piecewise function looks like. And you can see it's the what is happening and the where it's happening. And now this passes the vertical line test. If we drag a vertical line across this graph, there is no point where it's hitting 2 points at the same time. Even here I have an open circle and a closed circle. So the point is really just right here. This is empty space, so it is not violating the vertical line test. And that's how you graph a piecewise function. You have the what and the where. All right, I will see you next week for our video lectures then. Let me know if you have any issues with the